Hello, and welcome to the 2016 presidential debate hosted by the Calculus Foundation for Scholastic Success. Today, we're going to touch on some controversial issues that have been swirling around the math community. But first, let's meet our candidates.
Hello everyone, I'm so very happy to be here. My name is Hilary von Leibniz. I was born in the small town of Leipzig, Germany back on July 1st, 1646, and I attended Nikolai School at age 7. I eventually attended the University of Leipzig. Throughout my schooling, I was taught Aristotle's logic, but became unsatisfied with what I learned. I instead developed my own logical truths, which would later inspire my mathematical proofs. I'm very experienced across many fields, as I've made important contributions to the field of metaphysics, epistemology, logic, mathematics, physics, geology, and history. Now, I want to improve the lives of American citizens.
Okay, sure, yeah, you invented calculus. I see you're starting off with the lies already, Leibniz. I'm Donald Isaac Newton Trump, but my friends just call me conceited. I was born December 25th, 1642, in Wolfsburg, England. I attended the King's School at Grantham, and then I went on to pursue higher education at Cambridge University. Yes, the Cambridge University that Leibniz wishes he could have gone to. I obtained my master's degree in 1668 and then proceeded to make discoveries in mathematics, optics, physics, and now I am blessing all of you by expanding my knowledge of calculus into politics. By using calculus a la Newton, we can build a wall that will surely make America great again, because we have to solve our immigration problem.
Excellent, excellent. Now for the first question. The media has caught wind of the rivalry between you two concerning who the actual creator of calculus is. We want to discuss this calculus controversy. We know it was brought to attention in 1699 when Nicolas Fatio de Duiller accused Leibniz of plagiarism against Newton, and then again in 1712 with the publication of Commercium Epistolicum, which compiled the arguments against Leibniz. This controversy emerged because Leibniz published his calculus findings before Newton, but Newton claims to have discovered calculus first. Thus, the mathematical community wonders, who is the true creator of calculus?
Of course, I discovered my fundamental ideas in between 1664 and 1666 while at Cambridge University. The university was closed for a good part of this time due to the plague, so I worked at my family home in Woolsthorpe, Lincolnshire. I made a private summation of my work in October of 1666, but withheld my findings from the public and didn't publish them until 1687. Leibniz must have formally published his findings before me, but his findings were mere copies of my own. You see, we were actually in correspondence, sending letters of our findings to each other through a mutual friend, Henry Oldenburg, the secretary of the Royal Society. Henry had to convince me to share my ideas, but I soon became very wary that Leibniz would steal them, as I knew that he was kind of shady, and passed them off as her own. I broke off the correspondence and all was fine until October 1684, when Leibniz published her Nova Methodes Pro Maximus et Minimus.
Now, wait a second, Newton. I didn't steal my methods from you. I came to them independently. In fact, our views on calculus are entirely different. Sure, I saw your notes in the letters you sent, but seeing as though the ways in which we interpret mathematics differ so much, you can't possibly believe that I stole your ideas. It's not my fault you waited too long to publish your findings.
You mentioned that your methods of calculus are different. Can you explain your mathematical contributions and how they differ from the other candidates?
Well, I originally developed my calculus in order to find methods by which discrete infinitesimal quantities could be summed up to calculate the area of a larger whole. I believe this was because of my background in philosophy. I view the world as a sum of small entities and experiences, like a sum of its parts. Thus, while Newton thought of calculus in terms of motion, I viewed it in terms of sums and differences. The key idea was the differential, an infinitely small number that was almost zero, but could be used in the denominator of an equation. Thus, I thought of the notation derivative of y in terms of x to describe the quotient of two differentials. My other discoveries included using a differential triangle to discover the slope of a tangent line to a curve. It was by this method that I derived the power, product, quotient, and chain rules that many people are familiar with.
Leibniz was right in saying that I viewed calculus in terms of motion. As a physicist, I had a general method for calculating a variety of geometric objects such as planar area, arc length, volume, and surface area. I coined my version of calculus as a method of fluxions. I used infinite series and the already established power rule for integrals to calculate the areas under curves, and that allowed me to calculate the tangent lines to the curve. Calculus is my brainchild, not Leibniz's.
My final question for you both is, what are your plans for implementing your calculus?
As I mentioned earlier, my goal as president is a secure border. I plan to prove once and for all that our immigration problem is getting worse using calculus. Thanks to U.S. Census data, we can see our immigration population percentage over the last 8 decades. This graph can be represented with the equation y equals 1 half x squared minus 3.7x plus 12. Now, using Newton's method, you must first solve for 0, giving you this presented equation in step 2. Next, you must substitute in x, also known as the moment of x, for any x values, and the moment of y for any y values. This is a notation that I, myself, Newton, discovered. This is separate than what Leibniz presented. And then once you substitute in the moment of x and the moment of y, you then subtract the new equation and the old equation, and you put them together and subtract them from each other. After that, you simplify, as in shown in step 4. Next, you actually factor out the moment of x and the moment of y. So factoring out all the little zeros with the notation over them. And then you also eliminate any terms with the moment remaining in it. So any terms with the zero, the dot remaining in it after you factor out a moment, you then get rid of those, just strike them. I believe that they had no value in the equation. And that leaves you with the equation shown in step 5. Next, after you've reached step 5, you simply solve for the moment of y over the moment of x, and that gives you x minus 3.7, and this is what will later be known as a derivative. So now we actually have the derivative. We can solve the problem for this decade. So on the table in 2010, this is the 8th value over. So you substitute in 8 for x, and then in the end you see that we're actually seeing our population percentage of immigrants growing by 4.3% in the year 2010. And this is our instantaneous rate of change. We're seeing that the population and the percentage of the population that the immigrants are is growing by 4.3%, thus proving that a wall is necessary. It's time we put in this wall and make America safe again.
My goals are to continue decreasing the number of unemployed Americans by the rate of change that we've seen since January 2010 to December 2015. To find the rate of change, I use my method of differentiation. First, by using the U.S. Labor Statistics data table of unemployment statistics, I derived the equation that represented this decrease in unemployment. Then, by using my method of derivative y in terms of x, I differentiated the equation and found that the rate of change is
Negative 2.996%.
I want to ensure unemployment continues to decrease at this rate.
Well, that just about wraps it up. We're so glad you could both be here with us today. If we've learned anything, it's that you each created your own unique method of calculus. Thus, you too deserve to share the title of Creator of Calculus.